Have you ever wondered how your favorite foods stay fresh, safe, and delicious for so long? From the refrigerator in your kitchen to high-tech packaging in the supermarket, preservation is everywhere. But the world of food preservation is changing. New techniques are here, not just to extend shelf life, but also to protect nutrients, reduce waste, and keep our food safer than ever before. Join me as we explore the latest and most exciting preservation methods that are shaping the future of food. We always heard that juices and beverages need to be pasteurized or sterilized to prolong the shelf life. But today, you know that heat is not the only way to preserve fruit juices and beverages. A new wave of non-thermal processing is changing the game. These innovative techniques keep your juice safe without cooking it. That means the fresh taste, vibrant color, and essential nutrients stay locked in, something traditional heat methods just can't always promise. Non-thermal preservation, keeping beverages fresher, healthier, and closer to nature. The main purpose of pulse electric field is to inactivate pathogenic microorganisms while maximizing the quality of the food product. PEF, also known as non-thermal pasteurization technique, which involve the application of pulses of high voltage, typically 20 to 80 kV per centimeter, to foods placed between two electrodes. What happened to the microbes? This electric field causes tiny holes, pores, to form in the cell membrane. Because of these pores, the cell loses balance, nutrients and water leak out, or unwanted things can get in. If the pores don't close, the cell is damaged and eventually dies via electroporation. Imagine preserving food with pressure instead of heat. That's exactly what high-pressure processing, or HPP, does. In this method, sealed food packages are placed in water and subjected to extreme pressures, up to 900 megapascals. To put that into perspective, that's 6 times greater than the pressure at the deepest part of the ocean. This intense pressure is applied evenly throughout the food, instantly and uniformly, damaging the cell walls of bacteria, yeasts, and molds. The result: microbes are inactivated, and the food becomes safe to eat, without the need for cooking or chemical preservatives. Because there's no heating or cooling, HPP keeps foods tasting fresh, with their natural color, flavor, and vitamins almost perfectly preserved. Shelf life is extended too. Fruit juices can last 3 to 4 weeks, and meats can stay safe for up to 2 months, especially when combined with other preservation methods. The only catch: bacterial spores are resistant to high pressure, which is why HPP products are usually stored chilled or refrigerated. Fast, effective, and nutrient-friendly, high-pressure processing is shaping the future of food preservation. Another exciting non-thermal method is pulsed light technology, where electricity is transformed into super-powerful bursts of light. Here's how it works: a power supply charges up, a pulse device controls it, and a xenon lamp releases it, producing intense flashes of broad-spectrum light, from UV to infrared. When food is exposed to these ultra-bright, ultra-fast flashes, microbes are hit hard. Their DNA gets damaged, their cell membranes disrupted, and in some cases, the brief heat creates tiny bursts of steam inside the cell, literally breaking it apart. But there are limits. The light only works on the surface of foods or in clear liquids, and packaging must be UV transparent. Plus, it's less effective in oily or high-protein foods. Still, pulsed light is a promising tool, fast, clean, and chemical-free, offering a bright new way to make our food safer. Did you know magnets can help preserve food? In oscillating magnetic field technology, food is exposed to rapid magnetic pulses, lasting just milliseconds. These pulses, delivered at frequencies between 5 and 50 kHz, disrupt microbial cells and slow their growth, making food safer and extending shelf life. The effectiveness depends on how many pulses are given and how strong the magnetic field is. It's fast, non-thermal, and chemical-free, showing how even invisible forces like magnetism can protect our food. Another modern food preservation method uses ultrasonic waves. That's sound energy at more than 20,000 vibrations per second, far beyond what our ears can hear. Here's how it works: ultrasonic waves create tiny bubbles in liquids like milk or juice. These bubbles collapse violently in a process called cavitation. When the bubbles implode, they generate extremely high temperatures and pressures for just a split second. This explosive action releases free radicals, like hydrogen and hydroxyl, which attack and damage microbial cells. The combined effects, membrane disruption and oxidative damage, lead to the inactivation of bacteria, making liquids safer. On its own, ultrasound has limited power. But when combined with pressure, called manosonication, or with pressure and heat, manothermosonication, it becomes far more effective for sterilization. Last but not least, let's talk about food irradiation, also known as cold pasteurization. This process exposes food to carefully controlled amounts of ionizing radiation to make it safer and last longer, without raising the temperature. That means food keeps its natural taste, color, and nutrients, while harmful microbes are destroyed. How about the mechanism of action? Radiation energy damages the DNA of bacteria, breaking bonds and preventing them from dividing. If microbes can't repair this damage, they die or lose the ability to reproduce. Radiation can also disrupt cell membranes, split water molecules to form reactive radicals, and even affect enzymes, all of which inactivate microbes. Now, there are three main types of radiation used. First, gamma rays, produced from isotopes like cobalt-60 or cesium-137. They're extremely penetrating, up to 12 inches into solid food, making them useful for bulky or packaged products. Gamma rays deliver uniform doses, but since the radioactive source can't be turned off, strict handling and frequent replenishment are needed. Second, electron beams, E-beams, generated by an electron gun, like a giant version of a TV tube. They can be switched on or off, create no radioactive waste, and are great for thin foods like meat patties. But penetration is shallow, only about 3 centimeters, so they're less useful for large packages. Third, X-rays, produced when high-energy electrons strike a metal target. Like gamma rays, they can penetrate thick, packaged foods, but unlike gamma rays, the machine can be switched off and no radioactive material is involved. The downside, efficiency is low and costs are high, but this is the newest and still developing technology. Advantages of food irradiation include reducing or eliminating disease-causing microbes, keeping nutrients essentially unchanged. Food never becomes radioactive. In short, irradiation uses invisible energy to break microbial DNA, stop their growth, and extend shelf life, without cooking the food. It's science, safety, and freshness, all in one process.